Now let's look at evaluating logarithmic expressions. So if we want to evaluate log base 4 is equal to 64, we need to ask ourselves what power of 4 will give me 64. So 4 to the first power is 4. 4 squared, 4 times 4 is 16. 4 to the third power, we take that 16 and multiply by another 4, and that gets us 64. So 4 to the third power is equal to 64. So that means that log base 4 of 64 is equal to that third power, 3. Let's go ahead and try a couple of examples. So this next one, we're asking ourselves, what power of 36 gives me a 6? Well, 36 is bigger than 6, so that's kind of written a little backwards from what we were doing before. So instead of thinking in terms of integer powers, we need to be thinking of fractions instead. So in fact, the square root of 36 is equal to 6, and we can rewrite a square root as a 1/2 power, because remember, the power goes on the top and the root goes on the bottom. So the square root of 36, or the 36 raised to the 1/2 power, is 6. That means that we can say that log base 36 of 6 is equal to our exponent of 1/2. Now let's think about this one. We have log base 5 of 0.2. Well, 0.2 written as a fraction is 1/5. So let's think about that for a second. If we have 5 and we raise it to the -1 power, that's equal to 1/5. Remember, anytime that you have a negative exponent, it puts it on the other side of a fraction. So if we were on top, now we're on bottom. So if we say log base 5 of 0.2, well, that's equal to the exponent again, to -1. Remember that our exponent is the part that was in the x position in the exponential form, so it becomes the x position of our log form. Now, log base 2 of 32. So what would we have to do to a 2? Multiply it by itself how many times in order to get 32? If I say 2 times 2, well, that's 4. Let's multiply by another 2, 8. Multiply by another 2, and I get 16. And finally multiply by another 2, and I get 32. So 1, 2, 3, 4, 5 in order to get 32. So 2 to the 5th power is equal to 32. Log base 2 of 32 is equal to 5.